my name is Rien Gupta, and today I'm going to be talking to you all about an introduction to robotics mechanisms. Other than a way to move around with your robot must pack a lot of moving components in its space limitations. There are a few mechanisms that are very useful to get familiar with so you can make the building process very fast and smooth. In the next two videos, we'll talk about arms and lifting mechanisms, passive mechanisms, intake mechanisms, scoring mechanisms, and more advanced building tips. Without further ado, let's talk about arms and lifting mechanisms.
The most important part of a robot, besides their drive base, is the arm and lifting mechanism. Today, we'll talk about 5 different arms and how to use them. First, we have a swing arm. A swing arm is an arm that does not attempt to keep the mechanism at the end of the arm parallel to the ground. This is also the only arm that can rotate a full 360 degrees. This means that depending on the height of a field element, you may have difficulty interacting with it. This arm makes it difficult to consistently interact with the field, so most teams avoid using it. It is often a sign of experience if this arm is not used. Second, we have linkage arms. Linkage arms are the simplest way to keep whatever is attached to the end of the arm parallel to the ground. Usually, this is some kind of claw that can hold a field element. The simplest way of doing this is to connect the claw to 2 different beams which can rotate. We can take advantage of the fact that the distance between the beams stays the same and attach a claw there. For heavier claws, 4 rotating beams can be used, a pair attaching to each side of the claw. Third, we have a 6-bar. A 6-bar is a type of arm that reaches taller in a similar space to linkage arms. It is also a relatively simple to build and also keeps the claw level. Fourth, we have a chain bar. A chain bar is a type of bar that uses 1 beam but still keeps the claw level by counteracting the rotation with a chain. It also reaches slightly higher than a 4-bar, but is rarely used because chains might get caught on a field element and are slightly less reliable. Number 5, we have the double reverse 4-bar. This lifting mechanism lifts higher than all the ones previously mentioned. It is also significantly more advanced to build and requires some trial and error to determine how tall and how far out you want this arm to reach. It also keeps the claw level and doesn't have too much forward or backwards movement. This arm is useful in specific seasons where scoring zones are very elevated. We'll end this video by talking about an underappreciated but highly important part of VEX robotics, passive mechanisms. A passive mechanism or passive interaction is one that does not require the use of an extra motor. These are very useful because motors are limited in VEX IQ. We'll show you a few examples of passive mechanisms. First, the drive base is a very useful way to activate or power passive mechanisms. One such example is a plow. A plow is able to gather field elements using the push of a drive base, bypassing the need for a heavy and motor-driven intake system. The drive base can also activate mechanisms which require a sudden force, like slamming into a wall. However, these passive mechanisms can only be used once. Second, forks and slides take advantage of gravity. A fork passively holds field elements without the need for a claw, which uses a motor. A fork can also simplify and lighten a robot significantly. A slide takes advantage of gravity to passively push field elements to a certain position and is useful in intake mechanisms. Third, in some games, hanging on a bar can give a robot more points. This can easily be accomplished by adding a hook on the arm of the robot. Using the force from the arm, robots can hang like so. Fourth, rubber bands can be a very versatile type of passive mechanism. They can fit in tight spaces and can aid motors in lifting heavy objects, like arms. They can also move objects on their own, like in a rubber band gun, but they are only one use since they require resetting. That's why they're great for actions at the end of the game, like in the 2022-2023 season, where robots are allowed to reach over the wall into the scoring zone at the end of the game. VEX also has an obscure spring piece which can be used instead of rubber bands, and can be reset.
Alright everyone, that's for today's video. I really hope you guys enjoyed. If you have any questions, feel free to leave a comment down below. We'll be doing another video, Robotics Mechanisms 2. Please check that out, that will be very helpful, and I'll catch you guys in the next one. Have a great day.